Welcome to virtual algebra class. Today we are continuing our discussion of the geometry that's on the GED. And we'll be talking about area and perimeter with formulas. And I've titled this lesson 2 because this is the second time we're going to look at some area and perimeter problems with formulas. And in fact, it's the second time out of 3. We're going to work our way up to the level of complexity that we see on the GED. So the good news is by studying this subject, you'll really raise your score on the GED. Area and perimeters all over it. The bad news is it tends to go deep on the GED. There don't tend to be a lot of simple questions, more complex. And so definitely the types that we see today are fair game for the GED. You're going to see some like this. Okay, so the first thing that I want to point out to you guys is that a formula is an equation. So for those of you who might be familiar with the word equation, I highly suggest you go back to that last virtual GED unit that we did, or actually it was 2 units ago, on solving equations and inequalities, because we spent quite a bit of time here. But basically what an equation is it's 2 mathematical expressions that are equivalent to each other. They are equal to each other. 2 mathematical expressions that are equal to each other. And we know that the day we got that equal sign, the day we got an equation, was the day that we were able to start going both forwards and backwards in math. We were able to both simplify, like we've been doing since 2nd grade, but also start solving or moving things around from one side of the equal sign to the other. So that is what we will be looking at today. So let's get an example of a formula from the GED formula sheet. Let's take a look at the area of a parallelogram formula. The area of a parallelogram formula, if you look at the GED sheet, says A equals BH. Area equals base times height. When B and H are squished together like that, they're multiplying. But what we have here on this side is a mathematical expression. It's kind of a boring one. It's just one little letter, but it is a mathematical expression. And then I have another expression over here, and I can see that the 2 separations are equivalent. They're equal because of that equal sign. Does that make sense to you, ladies?
Yes.
Okay, so here's the really, really, really good news about an equation. An equation can be solved for any variable. So this is very mathematical language that I'm using here, so let's make sure that you guys know what I mean. First of all, if I say an equation is solved for something, it means that thing is alone and by itself. So like right now, this particular equation that I'm looking at has an A that's alone on its side of the equal sign. Can you guys see that? A equals BH. Can you see that the A is alone?
Yeah.
Yeah, good. So that means this equation is currently solved for A, okay? But the deal is it could be solved for any letter, which means I could use this equation to find A, I could use this equation to find B, and I could use this equation to find H, okay? It doesn't matter. And so that's what students don't realize. They're like, this formula only finds A. No, it could find A, it could find B, it could find H. I could use it for any one of those letters. Does that make sense? And the GED is not into straightforward problems. So the likelihood that they give you a problem where you just easily solve for A is unlikely. This thing's already solved for A. They're more likely to have you use the formula to find a missing B or a missing H and get a little more complex. Okay, so what I want to do is look at some problems like this, and we're just going to do some real simple examples today, just 1-step equations, and then next time we'll look at some more complicated examples. But does anybody have any questions about what I just said? Does this make sense?
Yes.
Okay, let me just mention to the entire internet world, I already mentioned it to you ladies, but solving 1-step equations is a prerequisite skill for this. So if you have never learned to solve 1-step equations, I would just pause this video right now. I would go check that out before I progress with this. So I have some area and perimeter 1-step equation examples, okay? We're going to use the GED formula sheet, and I might add We will also use our GED calculator because we're so super lazy. If you had any of these problems on the actual GED, you would have both the formula sheet and the calculator available to you. Now, some students get mad at me. They're like, oh, I can think of a different way to do this problem. Again, if you can think of a different way to do it, if you would do the arithmetic backwards, there's nothing wrong with that, okay? But I want to build up the skill because there will be problems later that are so complex you could never do them arithmetically. You would need algebra to help you. So we've got to build up our algebra muscles so that when those problems come along, we'll be ready for them. So I am going to use the formula sheet, which is the algebraic method of doing these problems. Okay, so here we go. Number 1 says, a rectangle has an area of 42 square centimeters. If the length of that rectangle is 5 inches, what is the width to the nearest tenth of a centimeter? So it looks like I've been given an area, I've been given a length, and I'm trying to find the width. What is the width? I need a formula that relates area, length, and width. Anybody, any ideas? Do you guys have your formula sheets with you? I didn't tell you to bring them this time.
LW.
Yes, exactly. Thank you, Kaylee. A equals LW, or area is equal to length times width. Now I'm going to grab up my red pen because I'm going to show you how students usually screw this up. This is a wrong next step, but I have a ton of students who go, hey, this formula is for area. I'll plug in the 2 numbers that I have and happily get this problem wrong. Anybody want to tell me what was wrong with that substitution?
The 42 is the area.
Exactly. 42 is not the length. You can't just plug in a number arbitrarily wherever you want it. It needs to go under the thing that it represents, or it needs to substitute in for the thing that it represents. And so we'll erase this nonsense here, and we will plug in properly. We will make sure the area, the A, turns into a 42. So right underneath where I once had an A, I will now write 42. Okay. Now, just like before, I won't change my equal sign, but I will change my L because I know what my length is. They told me my length was 5. You always substitute any variables out for known values, so I get a 5 here. And width is the thing I'm looking for. It's the mystery. So whatever is the mystery will remain a variable, a letter. And just like our last class, that's the substitution step. But this time, it's not just arithmetic to solve this. This is not a problem that I would just simplify. This is a problem where I have to get my letter alone. Can you guys see that my letter is not currently alone? Okay, my letter is over there with a 5, and so this is why I said you need those solving one-step equations skills in order to do the problems here. If I want to get rid of a 5 multiplier, ladies, what would I do?
Divide it.
Exactly, so I'm going to divide by 5. And that really, really important rule of algebra is whatever I do to one side of an equation, I do to the other. When I make a change, I make it to both sides. So I'll divide both sides by 5. On this side, dividing by 5 and multiplying by 5 cancel. So I do still have that W. And I didn't give myself enough space, W. And on that side, there's the math to do. And you can feel free to do it in your calculator, especially since it's not a pretty one. 42 divided by 5 gives us 8.4. Okay. So almost done with this problem, but last step is to check for any rounding directions. And I do see some rounding directions here. Do you guys see that?
To the nearest tenth of a centimeter.
Exactly, to the nearest tenth of a centimeter. Now, this one screws with students all over the place. They really freak out like, this thing, how am I going to round it to the nearest tenth? So can you guys see that this number already ends in the tenths place? 1 decimal is the tenths place, right?
Mm-hmm.
If it's not broke, don't fix it. There's no reason to round it. It already stops where it needs to stop, okay? So 8.4 is already to the tenths place. And so 8.4 what? This will be 8.4 inches. Now, I always have students say to me, Kate, you told me whenever it's area, it's measured in square units. Yeah, the area is measured in square units. Remember, area is covering over a shape. But the individual dimensions, like the width and the length, dimensions are just lines. So dimensions, this here was a width that we were finding, are going to be measured in plain old inches or yards or feet, linear units. Does that make sense?
Yes.
Wonderful. Okay, cool. We'll just do a few more examples like that and it'll be the world's shortest class, okay? So let's take a look at the next one. A certain parallelogram has an area of, what, am I obsessed with 42?
I guess so.
Has anybody ever read The Hitchhiker's Guide to the Galaxy? Or
No.
seen the movie?
No.
No, okay, sorry. The number 42 is supposed to be the answer to the, like, world's biggest question, but nobody knows what the question is. Maybe it's what's the area of my parallelogram, I don't know. Okay, so a certain parallelogram has an area of 42 square centimeters. If the base of the parallelogram is 8 centimeters, what is the height? Okay, so once again, I've been given an area. I have a base, and I'm looking for the height, and we have a formula that relates the area, base, and height of a parallelogram. Anybody, what is it?
A equals base times height.
Exactly, it's super easy. A equals BH. Okay, so my area, and we're only looking at the easy ones today, so yeah, score, because we're only doing one-step equations. So A equals base times height. So once again, we'll plug in what we know. For A, we'll plug in 42, and you guys can just, I like to use different colors for the things that change because some people have trouble with seeing symbols change. B, I can see my base is 8, so I'll turn my B to 8. And my H is my mystery, so my H will remain an H. And just like before, we have a 8 multiplying an H. We want to get that H alone. We are going to have to divide both sides of this equation by 8. 8 divided by 8 leaves me with just that H like I wanted. And you can do this kind of ugly math in your calculator. 42 divided by 8 is 5.25. And 5.25 what? Again, this is a dimension. It's just the height. So it'll be plain old linear centimeters. Okay, ladies, does this make sense?
Yeah.
I'd not be the least bit surprised if you got one of these 2 problems on your test, just like that. Super simple, easy points. Wouldn't have to think about it too hard like some of the other problems on the GED. So number 3 says a square has a perimeter of 22 inches. So of course, this time we're looking at a square with a perimeter of 22 inches. And it says find the side length of the square. So guys, do we have a formula that relates perimeter to side length of a square?
P equals 4S.
P equals 4S. And we'll plug in what we know. We always plug in what we know. So what do we know, ladies?
The perimeter.
We know the perimeter is 22. Now we don't change symbols like equal signs. We don't change numbers. And S is our mystery. It's the thing we're looking for. So it will remain an S. Awesome. How would I solve something like this, ladies?
Divide.
Absolutely. I'm going to divide by what?
4.
Yeah, thank you for humoring me. Some students divide by 22, but I want my S to be alone, so I have to divide by what the what's hanging out with S. So on the right-hand side, multiplying by 4 and dividing by 4 cancel so that my S is alone. And 22 divided by 4, I purposely did ones I thought that you might need to think about a little bit and wouldn't just pop into your head. So I get 5.5. And 5.5 what? That is just a dimension, a side length, so it's going to be 5.5 plain old linear inches. We good with that?
Yeah.
Okay, now those ones are really simple. Let's see some more that get a little more complex. Okay, so number 4, a square has an area of 64 square inches. Find the side length of the square. So we're looking at a square. We know its area, and we've been asked to find the side length. So what formula relates the area and side length of a square? And again, these ladies are looking at the GED formula sheet. They're not memorizing them.
A equals S squared.
Exactly. A equals S squared. We went right under that area section and found the area of a square formula. Great. And what do we know here? What value is known, guys?
The area.
Exactly. My area, my A, is 64. So I will substitute out my A for 64. My S squared will remain S squared because S is a mystery. And now I've got a little one-step equation to solve. Anybody remember what the opposite of square is?
Square root.
Square root. Brilliant. And so I'll take the square root of both sides. The opposite of square is square root, so I'll take the square root of both sides. So square and square root cancel, leaving my S alone on this side just like I wanted. And there's the math to do, the square root of 64. Now, this one is a perfect square, so I would hope that you have this memorized. It's very useful to memorize your perfect squares for the GED. But if you don't, your TI can do this, but it's a little tricky. A lot of people don't know how to do it. So I'm just going to show you. The square root button is actually featured in green. It's in green here on the left, right above the X squared button. Around there. And so to get anything in green, you have to press the second button. So I'm going to press second, and then I'm going to press X squared because right above it is the square root. And you should see that blinking. Square root symbol blinking. Yours might have a parentheses, it might not. It depends on what mode you're in. It doesn't matter for this particular problem. And I'll put 64 in there and I'll press enter and I get 8. So my S is 8. 8 what? 8 inches. Are we cool with that?
Yeah.
Okay, sweet. So pretty straightforward. I just want to look at one little complexity on the next one. It's almost the same, but it does have a calculator trick that you need to be aware of. Okay, so number 5 again says a square has an area of 42 square inches. And again, they've told me to find the side length of the square. So you might be thinking, dear Lord, Kate, why do we have to do the same problem twice? Well, let's take a look. Something different is going to happen with 42. So if I have my area of a square formula, because it relates the area to the side length, and I plug in what I know here, this time I know the area is 42. I don't change my equal sign. My S is my mystery. That's what I'm looking for, so it remains S, and I don't change operations. Okay, so I get this little formula to solve. 42 is equal to S squared. Once again, of course, the opposite of squaring is square rooting, so I'll take the square root of both sides. And once again, the square and the square root will cancel, leaving S alone. And everyone's like, really, Kate, was it necessary for us to do this twice? Here's why I wanted to do this. Again, if you press second and then the X squared button, and then 42, you may get the same answer out of your calculator. I just typed in the square root of 42 and got out the square root of 42. And that is not a good answer for a word problem, especially with this language I'm reading. It says find the side length of the square to the nearest hundredth. You guys hear that language, to the nearest hundredth? They want a decimal approximation, and my calculator is giving me an exact answer. My calculator is like, no, I won't round a decimal. I like exact answers. Whenever your calculator behaves that way, it won't spit out a decimal when you're expecting one. That means it's in math print mode. So you hit the mode button. Mode button's up at the very top here. I'm going to hit the mode button. And indeed, if you look there on the last line, you're going to see I have the word math print in black. Math print, like a mathematician, always prefers an exact answer over a decimal. So if it's going to give you an ugly decimal, long decimal answer, it won't do it. It'll just make it as simple as it can without going to decimal stage. If you want a decimal like a normal calculator, like an old-fashioned calculator, you're going to need to go arrow down over the word classic, press enter to select it, and now you're in classic mode. So I'm going to clear to get out of that screen. I pressed clear. And now I can do the exact same thing, square root. You're going to notice this time in my square root, when I'm in classic mode, that's when I see that parentheses I was talking about. And I press 42, enter, and this time I do get a decimal approximation. Okay, so if you want a decimal, make sure you're in classic mode. And that's a life lesson all over the GED. Okay, so I get this long, ugly decimal. 6.4807, and it goes on and on and on. Okay, now I can follow the rounding directions. Rounding directions tell me to take it to the nearest hundredth. Anyone know how many decimal places that is?
2.
2, exactly. So I'm going to keep these 1, 2 decimal places. So I'll consider the next number, the number about to die. It's a 0. It's not halfway yet. The halfway point is 5, so it's not big enough to make a difference. And so I will say that my side length is about 6.48 plain old linear inches because a side is a line. Not too bad, right? The only way this particular skill could get more complex is that they could hide from you, whether it's area or perimeter, kind of like the problems we did 2 classes ago. Okay, so, and looking at number 6 here, it says Mike has 74 feet of fencing with which to enclose a garden in his backyard. If he wishes to make the garden square shaped, what will the dimensions of his garden be? Which formula should I use? That's the big question. It's not explicitly stated here. Does anybody have a hypothesis?
P equals 4S.
P equals 4S. So you chose a perimeter formula. Tell me what evidence you saw in the problem that told you, yes, I should use a perimeter formula.
Fencing.
It's fencing. Yeah, we put our fence around the outside of a shape, around its perimeter. We don't put our fence over our garden. That would look ridiculous. Any other obvious signs that this was perimeter, this 74?
Enclose.
Yeah, enclose means to go around. More signs. I have one more. Do you see the last one?
It's just feet.
It's just plain old feet. That's 74 feet. Perimeter is measured in linear feet, whereas if it had been an area problem, that would have said square feet. So really good clues that we honed in on to tell us that we could use a perimeter formula. Okay. So P equals 4S. We'll plug in what we know. So what do we know?
74.
Yeah, 74. Is that the perimeter or the side length?
The perimeter.
That's the perimeter because that's how much fencing we have to go all the way around. And that, of course, is equal to 4S. And now, to solve this sucker, I would do what?
Divide by 4.
Exactly. I want that S to be isolated. That means solving for S means getting it alone. So I take away that 4 by division. On that right-hand side, it cancels. I balance out my work on the left-hand side. So my S will be alone, and it'll be equal to 74 divided by 4. Again, I'm using my trusty calculator because Kate hasn't even taught me to divide with decimals yet. Rude. Sorry. There might be one problem where you divide with decimals on your test, but there'll be plenty of algebra problems. So I'm like, let's focus on what's important. Okay, so, and I get 18.5. 18.5 what? 18.5 feet. Plain old linear feet because it's just a side length. Okay, but this one's interesting because actually the final answer, I didn't notice, I'm glad I just did, says what will the dimensions, hear the plural, of his garden be? What will the dimensions of his garden be? So most likely this would be a multiple choice answer. So you wouldn't have to just come up with this off the top of your head. But if I say dimensions, I'm expecting it's a two-dimensional, I'm expecting, you know, length and width. So even though it's a square, I would probably say it's 18.5 feet by 18.5 feet. And they might use the word by, or they might use a times symbol that means the same thing. And it has nothing to do with whether you multiplied in the problem. It's me being too lazy to spell by. Okay. Does that make sense? This was as complex as I wanted to get today. Okay, awesome. Then we're done. Hey, easy class. Thank you, ladies, for showing up. I love not talking to myself for real. See you later.